Alright folks, what we're going to do in this video is we're going to walk through the paired sample t-test example that we went through in class, except this time instead of in SPSS we're going to work through it in Stata. So again, have my data set open here, the paired sample T for the data set with Stata. Going to work through the screening here and then do analyses and auxiliary statistics in the next video. So the handout that we'll be working with, the paired sample T screening for Stata, working through this here for the screening stuff, and then again just as a refresher on the question. So what we've got in this example is interested in the impact of mental imagery on the regulation of subjective anger. So we've got an experimental study looking into manipulation. What we're doing is we're having people come in, have them rate 0 to 10 baseline ratings of subjective anger, 0 being no anger to 10 being extreme anger. Then we have individuals imagine a time which they experienced intense feelings of anger. After 2 minutes, what we're doing is then having them rate their peak levels of anger during that 2-minute period. We're then telling people to stop thinking about the anger memory and instead imagine a time where they experienced intense positive emotions. For each 20 seconds, particular participants are asked to rate current levels of anger on that same 0 to 10 scale every 20 seconds for a period of 2 minutes. And so what we're looking at is increases in rating from baseline to peak anger during negative imagery, and reductions of subjective anger from the first to the final rating, anger rating during positive imagery. This is going to be evidence for successful manipulation. Okay, so if we're going through, again, taking a look at our data here, so we've opened this up in Stata. If I open up my data editor, pops it up here. Here we have our participant number for this pilot. We have baseline anger, or where anger was when people start, their peak levels of anger during that negative imagery period, and then here we have every 20 seconds during the positive imagery ratings of anger. We're just going to be interested in the initial and the final ratings of anger during that positive emotion. So what we're hoping to see here is an increase during the anger induction, and then a decrease during positive imagery. Okay, so again, if we take a look here, all of our anger ratings 0 to 10 on a Likert type scale. What we're going to do is go up here, open up a do file. I've actually got one set up already for the paired sample screening and tests. So what we're going to start by doing here is we're going to go, remember, anything with asterisks is a note. Stata won't read that as a command. We're looking at accuracy and plausibility here. Okay, now remember what we talked about in terms of class when we're thinking about screening for our paired sample t-tests. Our paired sample tests aren't actually looking at ratings of anger at time 1 or ratings of anger at time 2. What they're actually looking at is the difference score. Basically, our paired sample test is just a one sample t-test or a single sample t-test looking at the difference scores. So for our screening, what we need to do is go through and create some difference scores that we can then go through and use to look at distributions and so on and so forth. So what I'm going to do is I'm going to generate a variable called anger difference, and this is going to be anger at the peak level subtracted from anger at baseline. Now remember, when we're calculating difference scores, particularly if they're over time, generally it's best to set the the score at the latest time point as first, subtracting from the initial assessment point. What this will do is it'll just make it so that the sign or the direction indicates whether or not things are increasing or decreasing. So we've got that for the anger manipulation, and then for the recovery, for the positive imagery, we're taking subjective anger, rating it at the last time point at the 6th assessment, and we're subtracting it from the initial one here. So if I go through and run both of these, we'll see that I've now created a new variable, anger difference. And so this is the difference in anger scores from peak anger to baseline during the anger imagery. And here is the difference between our final anger rating and our initial anger rating during the positive imagery. So we're expecting this to be positive because we're expecting increases in negative affect, increases in anger during the anger manipulation, and it generally looks like that's what we're getting. Here, we're expecting reductions of anger, so we're hoping things are going to be negative. That kind of looks like what it's looking like here, so we're doing pretty good. Okay, so what we're going to do, so we've created our variables that we're going to screen our different scores, and then I'm going to sort these by the different score for recovery. Going through, and it's looking like, again, if we're seeing here, again, this is a small set, so we can take a look. We can see that, yes, we do in fact have a missing value for participant number 18. Looks like we didn't have any anger ratings. We've got anger ratings at baseline and peak anger, but then we've missed anger ratings for the angry recovery period. And so what we would do is we would make a note that we've missing a value for participant number 18, but then we're going to go ahead and get rid of that. Okay, so after we've documented it, get rid of that person, go up here, save as. I'm just going to save this as a scrap file so we're not messing around with our original data. Okay, and then I could do the same thing if I want to take a look at anger difference, right? Sort there. But looks like with difference in anger scores, we're not missing any values there. Okay, so what we'll do then, so we've got one case with a missing value. What we want to do is now take a look at the distribution skew and kurtosis for our two different scores. So I go through and I've got tab stat. Remember that this is just requesting tabulating different descriptive statistics. So I've got tab stat for anger difference and recovery difference. In my statistics, I'm asking for sample size, mean, standard deviation, min, max, skew, and kurtosis. Okay. So I go through and run this. Taking a look, everything's looking pretty good here. So full sample, so not missing any data, mean, standard deviation. What I'm looking for is min-max values. Okay. Now for each one of these, because I'm looking at the difference in 0 to 10 scores, I could have a difference anywhere from -10 to +10. So here, all our values are within range. Here, all our values are within range. So we're looking not too bad here. Okay, so all of our values are within limits. So in terms of accuracy, plausibility, one case with missing anger recovery scores. Other than that, no values falling outside the bounds of what we would expect based on our data. Okay, and we could also take a look if I wanted to just go summarize anger start, anger peak, and anger 1 and anger 6. So these are all the raw scores that I'm looking at. And some just says summarize. If I go through and I run those, then I've got, 0 to 7, 0 to 9, 0 to 9, 0 to 8. All those are falling within bounds. So my data are looking pretty good. So I don't have any weird values or things that are falling outside of what I would suspect. So in terms of accuracy, plausibility, things are looking pretty good. Okay. So, okay, also looking at our univariate distributions here. So if I go back up and look at my difference scores, because this is really what is going to be analyzed with my paired sample t-tests. Skew for both of these is looking okay for anger difference. very, very close to 0. Almost no skew for anger difference. Anger recovery, a little bit of skew, not anything worth worrying about, but skew value is negative 0.42. In terms of our kurtosis values, looks like, again, remember, because Stata sets neutral kurtosis at a value of 3, a little bit of negative kurtosis for both of these. If I wanted to calculate what those actually were and not have to pull out my calculator, I can just hit display, sort of my kurtosis value minus 3. So for anger difference, I have a negative kurtosis value of about 0.64. I can do this again. Again, remember, if I just click on this, it pops it down into this. Go through and display here. So for my anger recovery, a negative kurtosis value of negative 0.33. So again, based on my distributions, everything's looking pretty much okay here. So one case with missing values. All my other values are plausible. Skew and kurtosis based on my indices here are looking not too bad. Okay, but what I would want to do is go through and take a look at my histograms and my box plots. And so what I've got here, again, this should be familiar based on previous videos. I've got a two-way figure, or a two-way graph. Just means I'm linking together and layering on a number of different graphs here. I've got a histogram for anger difference, and then before, in the past, we've used bins to indicate how many bins. Here, because I'm taking the difference in Likert scales, I'm just going to indicate discrete. And what this means is it's just going to use it's going to have a bin, or Stata is going to specify a bin for every unique value in the set, right? So we would do this if you have data that aren't really continuous, they're just kind of ordered categorical. There's only a limited number of values that the variable can take on. We can just hit discrete, and then it's not going to bin everything. It's just going to put things in, make a bar for all values in the data set. So we're going to try something different here. So we've got histogram for anger difference, discrete. We're going to treat these data as discrete, and then we're going to request a kernel density plot for anger differences, and then we're going to name this one H1. And the replace just lets us run this over and over again without having it give us an error. Okay, so I'm going to run this for anger difference. And here's my distribution of my difference scores. So the bars, values for 0, 1, 2, 3, 4, 5, 6, 7, 8. Remember, if we went through and took a look, minimum max is 0 to 8. So we're just treating these as discrete here. My kernel density plot is making this all look reasonably normal-ish. Okay, so no concerns here. But because I've named this graph and I've saved it, I can go through and run a histogram for my recovery difference score. Again, discrete, have a kernel density layered over the top of it, and this is going to be named H2. If I do that, then it pops this up. If I hadn't named these, it would have just wrote over the top of this, but because these are different names, we can look at them simultaneously. And so again, nothing too crazy going on here. Maybe a little bit of negative skew in the histograms. We've got this one plot with a value separated away from the rest of the continuous distribution. And the one thing to remember too is to think about what we're actually doing with these data. So here, remember that our recovery scores, this is the difference between our final anger rating and the initial anger rating during our recovery period, so during the positive imagery. So these zeros, right, these are people who didn't change. From the first rate, or from the last rating to the first rating, their anger stayed the same, which is kind of problematic in terms of thinking about our actual manipulation. Suggests that imagery didn't work, positive imagery didn't work in reducing these individuals' anger. So our negative values, we have people who have experienced reductions in anger over each one of from the first to the last anger rating during positive imagery. But then we've got two folks, or probably maybe three folks, handful of folks here who actually reported increased anger over the course of anger recovery. So these people reporting looks like a 1-point increase in anger from first to last. And here we've got someone with probably a 3-point increase in anger. So based on this distribution, not anything problematic in terms of whether or not we can run our paired sample test, but interesting to take a look and say, well, based on this histogram, it looks like at least for some of the people, most of the people had no change in anger over the 2-minute positive imagery. But then we had a handful of people who are reporting actual increases in anger, but for the most of the sample, most people are reporting reductions. For our anger induction, most people this looks more successful. Looks like people on average sort of about a 4-point increase, although we'll have to take a look back at means here. But distributions, either one, not looking like it's anything too worrisome in terms of distributions. So we can also take a look at our box and whisker plot. So again, box plot for anger difference. We're just indicating small sizes, labeling values as samples, just some stuff going on here. If we run that, that's fairly unremarkable. Box plots looking fairly symmetrical. Median value of 4. Here's our our max value at 8, minimum value at 0. Looks like our first quartile probably about 3. Our third quartile at 6. This is the interquartile range, but everything's looking pretty good there. Same thing if I do the same for my recovery scores. Again, median value at about -1. Here's our lowest value, highest value, interquartile range. But again, everything's looking pretty good here. So all in all, feeling pretty good about this. I'll go through and close these out. Okay, so in general, distribution's looking pretty good. For my anger recovery, had one person or a handful of people who were reporting increased anger, at least one person falling away from the rest of the continuous distribution, but otherwise not anything too bad. Okay, so we've looked at accuracy, plausibility, looked at our univariate distributions. Last thing I wanted to screen here for our paired sample tests is extreme values. Okay, and so what we're going to do is we're just going to request our z-scores for anger difference and anger recovery. Now remember, z-score is a user-defined program, and so we have to upload that into Stata. So if I were to go find it, z-score, it's going to Stata is going to go through and search different programs. If I scroll down web sources, here's my z-score package. If I hadn't downloaded that already, I could just click it there and it would install it, load it up. Again, help resources, things like that. Again, a nice aspect of Stata to go through and do this. But if you've gone through the single sample videos, you've already got this downloaded. So what we can do is we can just run z-scores for anger difference and recovery difference, and then we can just summarize descriptive statistics for our z-scores for both of these. Go through and run that. Check, we see our z-scores for anger difference, z-scores for recovery difference. Go through, take a look, and again, mean of 0, standard deviation of 1, and then minimum and max here. So at the low end for anger differences during the anger induction period, we see a low score about a little over 2 standard deviations below, to a max of about 1.7 standard deviations above the mean. Something similar with recovery differences. We see anywhere from about 2.5 standard deviations below the mean to a little over 2 standard deviations above. But again, consistent with everything that we saw in our graphs, nothing that would indicate problems in terms of extreme values, at least based on these data. Okay. So again, if we go through and take a look at our write-up for our paired samples, missing data, we have one case with missing values for anger recovery from 1 to 6. Want to make a mark at that. No evidence of problematic values. So with that case removed, we are working with a set of 24. talking about our distributions for anger difference, histogram and box plot, distributions for anger recovery, distributions in box plot here, no extreme values that we're finding, and so based on our recommendations, aside from that single case, nothing looking problematic, we can go ahead and run our paired sample test without concern based on the results of our screening here. Okay, so, oh, whoops. Don't want to look at that. All right, so that takes us through our screening. What we'll do in the next video then is walk through our actual independent sample t-test calculation of test statistics and auxiliary stuff there. All right.